All right, the greenhouse effect. So it is, just imagine, it's a hot, sunny day here in Southern California. One of those really hot days in the summer, and you have to go run an errand. You're gonna go pick up some bread for dinner. Maybe whoever's making dinner totally forgot to grab it. So you are sent on the errand to go pick up some bread. You go to the grocery store, you make your purchase, whatever other goodies that you decide to buy along with it. And you come back out to your car to drive home. Oh no, it is so hot inside. So hot. But you were only in the store for a few minutes. Why? How did this happen? It's, it's only a couple minutes. Wow. How could your car heat up so quickly? We are seeing the greenhouse effect happening just inside your car. So your car is kind of like an example of what's happening with the entire Earth. The sun's energy passes through your car's windows and it traps in that heat infrared energy. Thanks for checking in. Glad you made it. So we now have all of this infrared heat energy inside your car, and now it can't escape. It's trapped in by those windows. And this is what causes your car to get really, really warm really, really quickly. I know I experience this pretty much every day when I leave here. I do my best to crack my windows, but it's never enough. It's always just super duper hot and gross inside my car. I do want to show you a quick video. It's a little over 2 minutes, not that long. Quick overview.
Let me quickly review for you how this works. So again, the surface of the Earth is heated by the sun. The amount of energy that comes out of the Earth, geothermal energy, is a few thousand times less than what actually comes from the sun. So in certain places it can be important, but overall it's the sun that sets the Earth's surface temperature, not the internal temperature of the Earth. And when the sun shines on the Earth, some of it is actually reflected back to space. Again, more of it if it's on an ice-covered part of the Earth or where there's lots of clouds. And some of it is then absorbed by the Earth. And when it absorbs solar energy in the visible spectrum, what happens is the Earth heats up in response because it's absorbing energy. And when objects heat up, they emit their own radiation, but in a longer wavelength. And so that radiation then heads back towards space. If the Earth had no atmosphere, it would be about 30 degrees colder. So we would actually have a frozen planet. We are habitable because of our atmosphere, and because our atmosphere has some greenhouse gases, in particular carbon dioxide and methane, the most important of which is actually water vapor. Water vapor is interesting. We don't often talk about it as a greenhouse gas, but the reason it's important is it's like an amplifier. It turns over quickly. It lasts in the atmosphere hours to days to weeks. And so as a result, you can think of the other greenhouse gases, carbon dioxide and methane, as the dial, say on your stereo, but it's the water vapor that amplifies the effect because it turns over so quickly. And so what happens is these greenhouse gases, they absorb some of the infrared radiation, the long wave radiation, and re-radiate it both back to space and downward, but they act like a thermal blanket. So they essentially keep the Earth's surface warmer than it would be otherwise. And that's how the greenhouse effect works. And again, this isn't just a theory. We can actually say this is what causes Venus to be 460 degrees Celsius. We know this is, in fact, in the laboratory, we measure carbon dioxide by looking at how it absorbs long wave radiation.
All right, so I'm just gonna essentially take the general ideas that he had, and we will sort of explain them in a different way. All right, so the greenhouse effect is a natural phenomenon. We can see it happening. Without it, we wouldn't be a habitable place. We wouldn't be able to foster life. But we can also see it happening in other places, like Venus. He mentioned that Venus is super duper hot, and that's because it has an extremely thick atmosphere and way more greenhouse gases than we have in our atmosphere. So they really, really do a fantastic job of trapping in that heat, which is why Venus is so hot. It is unbearably hot, over 400 something degrees Celsius. So definitely not conducive for Earth type life. Anyway, so it helps keep us the right temperature. We are what's called a Goldilocks planet. We're not too hot, we're not too cold, we're just right, right temperature to foster life, in addition to all the other things like liquid water, all of those important things that we need for life as we know it. The greenhouse effect it acts like a blanket, and it traps just the right amount of heat to help that life persist. So I like to think of it as our protective blanket. There is some heat that does escape, but for the most part, it traps in the majority of the heat to keep us warm and toasty. Yay, a little nice warm blanket. I love a good lazy Sunday wrapped up. All right, so if the Earth had no atmosphere, we would be this really cold rock floating around the sun. All of the sun's radiation would just immediately bounce right off, and we wouldn't be able to be warm. And so this atmosphere that we need helps trap in that heat, that warmth, to give us that liquid water, which is essential to life. We would still have ice caps, we would have frozen water, but that liquid water is really important for all of our biological processes. So here's another diagram that I like. The sun beams its light down on us. Light, energy, thermal, infrared energy, which is heat, everything wonderful that the sun gives us. And when it beams down, it's going to warm up whatever it's hitting. Land, water, even some of the gases in our atmosphere. And then it bounces. Light is reflective. It can bounce around. And it bounces up back out towards space. But then our atmosphere comes into effect. We do have a bunch of greenhouse gases in our atmosphere, and those greenhouse gases interact with that infrared radiation, that heat energy. Some of it does escape back out to space, but a lot of it is reflected and bounces back off of those greenhouse gases. So just like your car on that hot day, our atmosphere is like those windows that let in all of that heat and light, but then it gets trapped inside. Okay, so greenhouse gases are useful. Without them, we wouldn't have life. But they almost always have this negative connotation. Why are they considered bad? Well, ever since the Industrial Revolution, we've been just dumping greenhouse gases into our atmosphere, mostly through the burning of fossil fuels, things like coal, gasoline. And if we have too many of those greenhouse gases, our atmosphere will start trapping in too much heat, just like putting on too many layers of blankets or clothes or whatever. It's going to trap in that heat. And the more blankets we have, the more layers we have, the more greenhouse gases we have, the less is able to escape. Less heat is able to escape, so we won't have as much escaping to space. It'll all just get more and more trapped into our atmosphere. So this is a repeat slide from Wednesday. I just want to reiterate all these important greenhouse gases. There are 5 to remember: water vapor, carbon dioxide, methane, nitrous oxide, and chlorofluorocarbons. Chlorofluorocarbons, or CFCs, they're found in many products that are aerosolized. They are a propellant. So things like hairspray and other like spray cleaning things, supplies, things like that. And what CFCs do is not only do they help trap in heat, but they were a huge topic of concern in the late 90s, 2000s, because CFCs interact poorly, or I guess detrimentally, with ozone molecules. Ozone is O3, so there are 3 oxygen molecules all bonded together, and it kind of destroys them a little bit. So I don't know if you've heard of the hole of ozone. It's generally kind of over by Australia, and CFCs are mostly responsible for that hole in the ozone. Since the 90s, that hole has closed a lot. COVID was a great help, and we like ozone because the ozone helps protect our Earth from the harmful radiation we can get from the sun. So we want ozone. It is a useful molecule, but CFCs not only are a greenhouse gas that help trap in heat, but they also destroy that ozone molecule that we need. Greenhouse gases are produced naturally: volcanoes, respiration, and decomposition. Volcanoes spew up carbon dioxide and water vapor. Organisms that respirate We are one of those. One of our products of aerobic respiration is carbon dioxide, greenhouse gas, water, greenhouse gas, and methane, believe it or not. We do emit quite a bit of methane whenever you fart. Part of the reason why it smells is methane. Methane stinks. But also in decomposition, we are made of carbon. Carbon is a very prominent molecule and atom in most of our organic chemicals. And when you die, when organic things die, they get decomposed, and that carbon has to go somewhere, and it's going to go up into the atmosphere. So there are natural resources, natural sources of these greenhouse gases, but humans are not helping. I do want to show you this really cool simulation. It is a FET, if you're familiar with FET. So let's start off with some nitrogen. Nitrogen makes up about 80%, if we're just making nice big round numbers, about 80% of our atmosphere. It's an inert gas. It doesn't react with a lot. Here we have an infrared flashlight. We can just pretend it's the sun, and it's emitting these heat particles. And as you can see, it's not reacting with the nitrogen. The nitrogen is not considered a greenhouse gas because it doesn't react with this heat. It just kind of does its own nitrogen thing regardless of what's happening. Now let's try carbon dioxide. We know carbon dioxide is a greenhouse gas. Let's see how the heat will react with that. As you can see, it was reacting with that heat, that infrared radiation, and it was bouncing it around. More often than not, it will reflect that and bounce it back down to Earth, down towards Earth, where that will continue to heat up whatever it comes into contact with: land, water, organisms. Same thing with something like methane. Once again, it's interacting. It's bouncing them, spitting them out wherever. More often than not, that will be heat particles bouncing back down to the Earth's surface. All right, now we're going to focus on anthropogenic or human-related greenhouse gases. The three biggest ones that are human-related are carbon dioxide, methane, and nitrous oxide. So here is a sort of pie chart looking at all the different contributors, the biggest contributors to greenhouse gas emissions. So the biggest slice here are electric power stations. So whatever power plant, all over the world, the majority of power plants are run by fossil fuels, burning coal, burning oil and diesel and things like that. They are just dumping all of that carbon that they're burning. So fossil fuels are made almost exclusively of carbon because they are dug up from the depths of the earth. They are made of organic compounds that have been pressed with a bunch of pressure and heat and condensed into flammable and useful for combustible, that's the word I'm looking for combustible chemicals that can run our power plants. Next biggest slice will be industrial processes, things like factories. Transportation fuels, this includes things like jet fuel, diesel, gasoline. Land use and biomass burning. So this comes down to things like what we're seeing in the Amazon. They are slashing and burning a bunch of land to make room for things like agriculture. Well, the best way to get rid of things that you cut down is to burn it. Well, all of those trees and whatever, all that biomass is made of carbon. It's an organic molecule. And that carbon has to go somewhere, and if you burn it, it's going to go up into the atmosphere. Agricultural production, so not just food like growing plants and produce, but also on the other side, the animal side, things like livestock. Plants take a bunch of water, but they also, they are respirating, and they need to emit and take in and have a process with those greenhouse gases as well. But on the other side, if I have a field full of corn that's a few acres, it's going to take forever if I try to pick all that by hand. So I need big monster machines and things like that to do it efficiently, but they run on fossil fuels more often than not. Next up, fossil fuel retrieval, processing, and distribution. So fossil fuels are found deep, deep, deep down in the Earth's crust. We have to get them somehow, and more often than not, we have to burn those fossil fuels to get down there. We have to process them. When we pull up crude oil, It's not, we can't just like put that in our cars or burn that in a factory. No, it has to be refined. There are so many things that come from crude oil, and there is a processing that happens to get all of those various different products. And of course, distribution, we have to send all of these fossil fuels somewhere, and they have to get there by things like trucks, big freighter ships, and things like that that run on fossil fuels. Next up, residential, commercial, and other resources. Whatever we're doing as individual citizens and people, we are contributing. And lastly, little slice here, waste disposal and treatment. This goes for both like things like refuse and garbage, how we dispose of that. Is it just sitting in a landfill? Is it getting burned? A lot of places burn their garbage because they don't want just like a bunch of landfills. You gotta make room for more trash. But it also applies to things like biological waste. How are we getting rid of that? A lot of places also burn biological waste. That's full of carbon and methane, gonna go straight up into the atmosphere. I do want to focus on these last ones. They name these big three specifically and their biggest contributors. For carbon dioxide, biggest contributor, fossil fuels in those power plants. Kind of makes sense. We're burning them to release the energy to give us power. It's going to be a big one. For methane, our biggest one is going to be agriculture. This is going to be focused more on livestock, cows, pigs, not as much poultry, definitely not fish. Overfishing and fish farming is a completely different topic. I don't want to get started on that. But cows do very few things. They eat, they sleep, they poop, and they fart. Methane is a huge, big component of farts. Cows fart a lot. Same with pigs. Going up in the atmosphere, methane is a greenhouse gas. And nitrous oxide, again, this light green is our agricultural processing. Pretty big slice there for our nitrous oxide greenhouse gas. Okay, so now you feel gross, you feel bad, humans are garbage, we're destroying the planet. What can we do? I do want to call your attention to one of the biggest sort of myths out there. Big corporations. They are the largest contributors to greenhouse gas emissions. And they have spent millions and billions of dollars on PR campaigns, ads, all that stuff to make you feel like, as an individual or small family group, whatever, that your impacts are just as important as their impacts, and they make just as much of an impact and significant. They're significant to our climate change crisis. Don't believe their lies. They're paying incredible amounts of money to not only improve their image in terms of emissions, but they also pay a lot of money to politicians to have them in their corners. They don't pass legislation, limiting their emissions and carbon and stuff like that. So don't believe their lies. You as an individual aren't making nearly as much of a negative impact as these big corporations. I found this really cool infographic. If you do want to look at it a little bit closer, we're just going to briefly go over it. But there are 20 companies that produce, how much was it? 35% of the carbon emissions. 35% are just from these top 20 companies. So as of 2017, it's a few years old now, but let's just take a look at some of the big top ones. Oil company, oil and natural gas company, oil company, coal company, oil company. They're all like petrol. That's another word for oil. They're all big oil fossil fuel companies. And they are just dumping. So as of 2017, all 20 of these emitted 1.3 million metric tons of carbon dioxide. Just these 20 companies. Crazy. That's an insane amount of carbon. So if you do want to take a look at that, it is linked here in the slideshow. All right, so it may seem plausible that yes, maybe I am particularly awful in terms of like how I buy my things, use my things, and carbon emissions and things like that. It is plausible. Everybody has a carbon footprint. Even people who don't have a car or never travel, things like that. Everybody has a carbon footprint. But our contributions pale in comparison to these large corporations. They have just incredible amounts of emissions on their plate. And there's no way that a single person could ever create as much as they do. So we can make a difference. The biggest differences in turning around our climate change crisis right now by two main things. We can work towards passing legislation that will limit their carbon emissions. If we have to limit their carbon emissions, then they have to find new solutions to use non-fossil fuels and things like that, because most of them are fossil fuel companies. We can also focus on electing officials who stand behind green solutions. They're not going to be tempted to take bribes and money from these big corporations to kind of let things slide. If we elect people who are, here for the planet and they want to have green solutions, those are the ones we have to stand behind and elect into office. Okay, as an individual, there are some things that you can do to help reduce your impact if you're concerned about that. First up and foremost, reduce your air travel. Jet fuel is so much worse than something like gasoline that you put in your car. It is what we call high octane, so that means it has way more carbon in it, because some of those bonds in jet fuel, we're just breaking apart carbon. And not only are you already in the atmosphere where all that exhaust is going on, but it is much more volatile. It spews much more carbon than something like your car with unleaded gasoline. Drive less, just in general. Do things like carpool, ride your public transportation, ride your bike. Public transportation has a little asterisk there when it is safe again, when you feel comfortable doing something like taking the train or the bus. Use energy efficient appliances in your home. Most of you have Energy Star appliances. Energy Star has been around for a while, but as things start to wear out, you might need a new refrigerator or washer dryer. Over time, technology does get better. We have more and more advancements, so the more new stuff is more efficient than the older Energy Star energy efficient appliances. So really getting into our most efficient appliances is the way to go for that. Be mindful of your energy use. Do things like turn out your lights when you leave the room. Pretty simple. My husband really struggles with that one. He's often very distracted, and his brain's already on the next thing. He walks out of the room and completely forgets about the light switch. But we don't know necessarily each person. Depending on where you live, you might get your power from different power plants. And power plants get their energy through various ways. Some are more green than others. Some use fossil fuels. Some have, hydropower or wind power or things like that. This one is the biggest stab in the heart for me. Eat less meat. I love meat. It is tasty. It is yummy. But if you can cut back on anything, beef is number one. Those cows really fart up a storm and contribute a lot of that methane into the atmosphere. So we also have to take into consideration processing plants. We can't just take a cow and plop it on a dinner table. We have to process it. We have to cut it up. We have to, get it into what we see at the grocery store. And processing plants take energy. More often than not, they're getting their energy from power plants that run on fossil fuels. So there's two factors there in terms of eating less meat. We can also waste less. The energy it takes to create products usually comes from power plants that burn fossil fuels. So whatever factor we're at, the energy it's running on comes from a power plant that most likely burns fossil fuels, especially globally, places that are known for manufacturing, places like China or the Philippines or Taiwan. They are less likely to have renewable resources for their energy source. Recycle, this one's kind of self-explanatory. It takes less energy to reform materials, so things like aluminum cans, certain plastics, glass, than it is to create them from scratch. All we have to do is add a little bit of heat, morph it, reform it. Instead of coming from scratch, it takes a lot more energy. So if you think about, like, we're going to take some silica or sand, heat that up until we can get liquid glass, and then we have to form that glass bottle. But if it's already in glass form, it's going to take less energy to make that new glass bottle. Donate old clothes. clothes takes energy, whatever factory they're made in. It's if it can benefit someone, that now great, we're going to reuse that clothes, that t-shirt, that pair of jeans, whatever. We're not buying a new pair that came from potentially a factory that was run by fossil fuels. Big one for me, take care of your e-waste responsibly. We live in a very technologically advanced world at this time. Everything has a battery. I know that I've definitely in my time experienced some dead batteries that start leaking their battery acid and they get kind of corroded and gross. Well, if you just toss that and chuck it in the trash, that goes to a landfill. It seeps into the ground and maybe even into our groundwater. So you could be drinking harmful battery grossness. It's not good for you. Shop sustainably. Most places here in California make you use reusable bags, or you have to pay for the really like thick plastic ones. But if you bring your bags, we don't have to then have a supply and demand for those or I guess less reusable thick plastic bags. And buy higher quality things that will last longer. Kind of makes sense. If we're buying a bunch of cheap stuff that has a high turnover rate, it wears out quickly. We have to keep buying more. But if we spend a little bit more on the front end and get something that'll last much longer, we can cut down on that energy production in making those new products faster and faster. So a little bit of effort, a little bit of time, we can all work together and help save our planet.